All right, so lesson 10.1, video number 2. So let's try to apply this arc length formula, these arc length formulas. All right, so it says, what is the length of arc AD? Express the answer in terms of pi. So when it says in terms of pi, basically what it means is don't round, leave pi in your answer, okay? So we want to find the length of arc AD, which is right here, right? In order to do that, I do need the central angle. Notice I don't have the central angle, but I do have 1, 2, 3 other central angles, and I should know that these 4 central angles have to add up to 360. So if I take the angle that I want, I'm going to call it x, and I add it to 73, 43, and 104. Those should equal 360. So again, you just add up the 3 you know. So this gives you x plus 220 equals 360, and subtract 220 on both sides. X equals 140. And there we go. This angle measures 140 degrees, which means this arc measures 140 degrees, and we can find the length of our arc using the degree formula, because we're in degrees. So S equals N over 360 times 2 pi r. Now again, sometimes I like to do this 2 pi r thing separately, so I will. So that's the circumference. Your radius is this 4, so that radius, so 2 pi times 4, and that's just going to be 8 pi. So that's our circumference. So to find our arc length, we're taking 140 out of 360 times that circumference of 8 pi. Right? Again, remember that 180 out of 360 is about half the circle, so we're almost taking half of this 8 pi. Okay? All right, so we need to simplify this. So let's simplify this fraction first. We can cross off the zeros. And then I know that 14 and 36 are both divisible by 2, so let's divide by 2. So I get 7 over 18 times 8 pi. I think 7 and 18 are done being simplified, so then this 8 goes to the top, right? Multiply 7 times 8, you get 56 over 18 pi. I'll put the pi after. Ignore that little line there. And now 56 and 18 can be divisible by 2. So that's going to be 28 over 9, and I believe that is simplified, and put the pi. And that would be in a length of units, right? 28.9 pi units. And again, if you multiply that out, you would get an actual number, which would probably make more sense to you. Now, I do want to just quickly show you what if it was given to you in radians. So let's convert that angle into radians. And again, you're not going to do very much of this, but just for because we're honors, just for our kicks. So to find my theta, I'm going to take my angle of 140, and I'm going to multiply by that conversion factor. Now this is 140 degrees, so that means I put the pi on top and the 180 degrees on bottom. This is how we'll convert. So the 140 goes on top, we'll put the pi there, the 180 goes on bottom, and let's simplify this, right? The zeros cross off, I can divide both by 2, that's division by 2, so we get 7 over 9 pi. So that is that angle APD in radians, 7/9 pi, or 7 pi over 9, whatever you want to do. So now, to find the arc length, we take the angle and we just multiply by the radius. So that'd be 7 over 9 pi times, and our radius is 4. Again, that 4 go to the top, and that's 28 over 9 pi units. Same exact thing. Right, so it just depends on when you want to take care of the 360, the 180, all that fun stuff. All right. So again, the blue is much more than you need to know. The red's what you need to know. And again, if we were to say it around, I would just type in 28 over 9 times pi in the calculator. Okay, so now example 4, it says relate the area of a circle to the area of a sector. So now we're looking at sectors. And when you take a look at a piece of, or a circle, right, think of it as a pie. Your sector is a slice or a piece of pie. Slice of pie, right? We want the area of that sector. And again, when you talk about the area of a sector here, again, it is the region bounded by the 2 radii and the intercepted arc. We want to know what is the area here of sector MQN. So the area of a circle is pi r squared. So just like we did with arc length, to find the area of a sector, you simply take the angle out of 360 times the area formula pi r squared. And there's our formula. So I have everything I need to know. I have my angle measure 78. I have my radius 10. So I will find the area first. So the area of the circle is going to be pi times 10 squared, which is 100 pi. And again, I'm going to leave it in terms of pi. So I'll put that right here. So leave it in terms of pi, but it could ask you to round. Just pay attention. And now to find the area of the sector, we're going to take 78 over 360 times 100 pi. Now, this 78 is almost close to 90. 90 is 1/4 of this. So 1/4 of 100 is 25. So we're looking for something around 25 pi. Okay, so keep that in mind as you go through this. So I'm going to simplify this. So 78 and 360, I can divide them by 2. So that's going to be 39 over 180 times 100 pi. I think you can simplify 39 and 180 more, divide them by 3. So now we get 13 over 60 times 100 pi. 13 is prime. It does not go into 60. So now we're going to multiply the 13 times 100. So now I have 1300 over 60 pi. And now I'll simplify, cross off a 0. I believe that 6 does not go into 1300, but I believe both are divisible by 2. Right? I would have tried 6 first, but it's not. So when you divide 130 by 2, you get 65. When you divide 6 by 2, you get 3. Right? 3 does not go into 65. It goes into 66. And that would be pi. And then this is going to be centimeters squared because we're doing area. And again, 65 divided by 3 is about 20, right? Which is close to 25 pi. All right, next, I got a couple more problems here. So the next one talks about a segment of a circle. So as we continue on with this area talk, we can find the area of a segment of a circle. And this is the part bounded by the arc this is the part of the circle bounded by an arc and the segment joining its endpoints. So we're looking for just this tiny little sliver right here, okay? And when you're looking for the area of a segment, to find the area of the segment, you simply take the area of the sector and you subtract the area of the triangle, right? And now we have this nice formula from topic 8, area equals 1/2 AB sine of C. So remember, you can use that with the side angle side case, and in your picture, you should have a radius, and a central angle. I'll put theta there, but angle, and that's side angle side. Okay. So when you really use this, right, it's actually going to be 1/2 r times r, which is r squared, sine of your angle n. I'll put that in parentheses. So there you go. We're going to use that. So in this picture here, I need to find the area of the sector, right? So to find the area of the sector, I'm going to find the area of the circle, which is pi times 8 squared, which is 64 pi. And then I'll take 60 out of 360 times 64 pi. Okay. Now, it's saying that it doesn't say in terms of pi, so I'm going to go ahead and type this in the calculator. All right, when I get that, the area of the triangle is going to be 1/2 times r squared times the sine of 60. So I'm going to take this and I'm going to subtract 1/2 times 8 squared sine of 60. And I would just type all this in at once, right? That whole thing. Make sure, because you're using sine, that you're in degrees. And when you type all that at once, you get 5.79, which would round to 5.8. And this is still going to be an area, it's segment area of a segment, centimeters squared. Okay, and then last but not least, number 6 here. It says, Chen uses circular cardboards to make 18 watermelon coasters to sell to craft fair. He paints one side of each coaster with special paint. Each jar of paint covers 200 inches squared. Will one jar of paint be enough to paint all of his coasters? So we have 18 coasters, and we want to paint one side of them. So here's the coaster right there, right? The coaster, sorry about my spelling, coaster, there's an A there. AS. The coaster is a sector of this circle, right? So we need to figure out the area of this sector, and then we have to multiply by 18 and see how that compares to 200. right? So this 8 is the diameter. To find the radius, we take half of 8, which is 4. So to find the area of the sector, first I start with the circle, pi times 4 squared. That's going to be 16 pi. And then I'll take that and I'll multiply it to find the area of the sector by the angle, which is 72 out of 360 times 16 pi. Now, instead of doing just that, then I'm going to take this number and multiply by 18. So I need 18 of them. So I'm going to take this and multiply by 18. Let me show you how this is done in Desmos, just in case we forget where the pi button is, right? So let's go to Desmos. So I'm going to put the 18 out in front. So 18 times, and we're doing what? 72 divided by 360, arrow to the right, times 16, I'm sorry, times 16 pi. And you can type out the letters pi, and it shows the pi, or you can find the pi button down here in the keyboard right there. Pi. And I get 180.95. I would round that up to 181. So we have 181 inches squared to paint. That is less than 200 inches squared. So yes, one can will work. Or one jar, right? Yes, one jar. Okay, last problem of this video. Let's take a look here. All right, so now it says, part B. It says, okay, he puts decorative tape around the edge of each coaster. How much tape does he need for each coaster? So understand this, right? That when you cut out the coaster, it's not just the watermelon edge that gets taped. It's going to be this radius, let me use blue. It's going to be this radius, and the watermelon edge, that arc. So we need to find the radius, and the length of that arc S, right? So let's find the length of the arc. It's part of the circumference. So let's first find the circumference, 2 pi r. Remember, that's your diameter, so your radius is 4. We calculated that, so 2 pi times 4, which is 8 pi. And now to find the length of our arc, we take 72 out of 360, times it by 8 pi. When you multiply that out, you get 5.026. So I'll go out around that to 5 inches. That's fine. So that's the length of that arc. So to find the amount of tape I need, I have to add the 2 radii, 4 plus 4, and the arc length 5. 4 plus 4 plus 5 is 13 inches. And that's how much tape he needs for each coaster. All right, nice. Okay. Good luck with this lesson.